Okay, for next question, it's given that a 5 kg ball and a 10 kg ball approach each other with equal speeds of 21 meter per second. We have to determine the speeds after the elastic collision. So let this be ball A and ball B. This is a 5 kg ball and this is a 10 kg ball, and they are approaching each other. So they are approaching each other with equal speed. So let its speed be u1 and its speed be u2, and both being 21 meter per second. So this is 21 meter per second, and we are going to use the sign convention. For the sign convention, if the speed is in the right direction, I'm going to take it as positive, and the speed is in the left direction, I'm going to take it as negative. So here u2, I'm going to take it as negative. Okay, so this was before collision. Okay, now these balls collide. So when they collide and after separation, they will go back in the opposite direction. So this 10 kg ball will go back in this direction, and this 5 kg ball will go back in this direction, and let its B final speed be V1 and its final speed be V2. And this, I'm going to take this as per the sign convention. This is positive and this is negative. So we have to find V1 and V2. So these are two variables we have to find. That means we need two equations. So for elastic collision, we know that the coefficient of restitution is 1, which is given by the coefficient of restitution E is equal to 1. This E is coefficient of restitution. Okay, so this is the coefficient of restitution, and we know that coefficient of restitution, that is E, it is given by the velocity of approach divided by the velocity of, sorry, its velocity of separation divided by velocity of approach, which is equal to 1. Now the velocity of separation, that is after collision, this was after collision. Okay, so velocity of separation is given by v2 minus v1, and here the v1 is a negative, so I'm going to use the sign convention. Let me use it as negative v1, and the velocity of approach is given by u1 minus u2, and let's put in the respective values. So if I go ahead and put in the respective values of all these, so we don't know the value of u2, so minus of minus is equal to 1. U1 is 21 and u2 is negative 21, so it's 21 minus 21, which is 42. So which gives me v1 plus v2 is equal to 42. That is the equation 1. Okay, and to get the second equation, we are going to use a law of conservation of momentum. And according to law of conservation of momentum, initial momentum is equal to final momentum of the system. So I'm going to use the law of conservation of momentum here. So using law of conservation of momentum, this is m1 u1, that is the initial momentum of the system m2 u2 should be equal to m1 v1 plus m2 u2. M1 is 5 kg, U1 is 21, M2 is 10 kg, and U2 is negative 21. M1 is 5, and V1 is negative V1 with the sign convention, plus M2 is 10 and V2 is positive. So 5 to 21 is 125, this is minus 210, this is negative V5 V1 plus 10 V2, which gives me negative 105. 105 minus 210 is negative 105. So let me take negative 5 hour. So this is V1 minus 2 V2, and negative negative cancel. This is 21. So we have this equation V1 minus 2V2 is equal to 21. This is the second equation. Okay, so we have got these two equations. This was the first equation, and this is the second equation. Let's go ahead and solve these two equations. So V1 plus V2 is equal to 42, and V1 minus 2V2 is equal to 21. But the equations, this gets cancelled. V2 plus 2V2 is 3V2, 42 minus 21 plus 21, which gives me V2 is equal to 7 meter per second. Okay, so this is V2, and let's calculate V1, which would be equal to 42 minus 7. So this is equal to 35 meter per second. So V1 is 35 and V2 is 7 meter per second. We can use the sign conventions, and because V1 is the left direction, so this should be negative 5 if we want to denote the directions. Okay, so this solves our this numerical, and let's move on to next one. Thank you for watching.